Hello and welcome to the next part of the Explain Ash video tutorial covering the information that you get based on active session history and in fact also real-time signal monitoring. Coming from the previous part where I've covered the activity timeline, we now are heading to the final part of the Explain Ash report, which is the activity on execution plan line level. So in principle, what Explain Ash does is it enriches the output that you get from DBMS Xplan display functions. So what you see here in principle is the normal output that you get from DBMS Xplan.display cursor, but using this injection technique that Adrian Billington, for example, used in some of his scripts, I add here various columns to this output. So this is the output from DBMS Xplan display cursor or display AWR function, and more columns are basically then added to the output. So with some tricky string manipulation operations, these additional columns are added. What you get as additional columns depends on various factors. One factor is that you can actually configure on the script configuration level. You can configure which columns to show on execution plan line level, and you can also influence this here via this command line here. This last parameter, this comma separator list of columns to show height, is basically where you could in principle specify the columns that should be shown or hidden on execution plan line level. If you're interested in customizing this, just check the corresponding script part where it's explained. You can use leading minus signs for the columns that you want to hide, or simply state the columns that you want to see. The default probably makes a lot of sense, so probably there's no much point in actually customizing this, but at least it's possible in the script to customize this. Then it depends on which additional columns you get, depends on what information is actually available and which options you have requested. For example, if you use here not the default, but for example would not specify this monitor option here, then some of the columns that come from real-time signal monitoring would simply not be shown on execution plan line level because you haven't selected the monitoring option. So this is another factor here that influences what you will get on execution plan line level. Of course, again, the default probably makes sense, which is show all available information. And then again, even if you specify to show all possible columns, all information that is available, if, for example, the real-time signal monitoring information is no longer available, then these columns will still be missing, of course, because there is no monitoring information available. So let's start on the left side of this execution plan output. So these two columns you don't get from the DBMS Xplan display functions. So these are two columns that Xplan Ash adds here. One is this parent ID, which is quite helpful for more complex plans, so that you get immediately an idea what is the parent operation of a particular operation. I think this would be a column that would be useful for the default DBMS Xplan output to show, but it's missing for some reason, so I add it here. So you have this parent ID information, and you have this order of execution information. This is only shown for serial plans. So if you have a parallel plan, then this column here will not be shown. The reason is simple. The underlying logic that derives this information here is based on this, let's say, standard approach that the execution starts at the first leaf. So you can see here, this is the first leaf or the leaf with the lowest ID in the execution plan. This is where usually if you do not have one of these various exceptions, then this is where the execution starts in a serial execution plan. So this is the operation that gets executed first and so on. This is how this logic works. However, for parallel execution plans, the order of execution is different, so it does not adhere to this default approach for serial plans. There are different rules that apply to parallel plans, and since these are more complex, and I haven't spent the time yet to think about how to implement them in the script for parallel plans, this column simply will be missing because it will be misleading anyway. And even for serial plans, as I just pointed out, if you have one of these exceptions to these to this standard rule, again, this order of execution information here will be wrong. So there are definitely cases if you, for example, have scalar subqueries or some other of these exceptions, then this order of execution here will be wrong. Nevertheless, for serial plans, I leave this column here. I keep it in the output, even if it could be misleading, because for the standard serial plans, it should be okay and might be helpful for those that struggle with understanding what is the actual order of execution. Yes, then the next columns are all the default columns that you also get from the DBMS Xplan display output, so there is nothing added or modified here. If we if you have requested the monitoring, real-time SQL monitoring information, and if it is available, then starting with these columns here, this is the real-time SQL monitoring information, which in principle corresponds to what you get from the actual real-time SQL monitoring report. So here we have the corresponding official real-time SQL monitoring report, and you have the columns execution, actual rows, the PGA, and the temp information, IO requests, IO bytes, and so on. All this will be then shown here also. So you have here the executions, actual rows, PGA. If there was any temp usage, then this temp would also show up. So Xplan-Ash here tries to hide all the columns that do not have at least one row populated. So if no row is populated, then the column will simply not be shown here. So if we, for example, switch to a more complex parallel plan, then you will see here that we have more of these columns from real-time SQL monitoring. We have these executions again, actual rows, PGA. In this case, we also see here this temp activity, maximum temp, maximum PGA is it actually, to be more precise. Then we have here the IO information, read bytes, write bytes, read requests, write requests. So this is all the information that you get from real-time SQL monitoring, and actually will not be there. All of these columns will not be there if the real-time SQL monitoring information is not available or not requested via the options. The next columns are now based on active session history. So these columns will always be there if you are in the active session history mode of Xplan-Ash. There's also a row source statistics mode of Xplan-Ash that I will cover in a separate series. So Xplan-Ash has more to offer, different options that are then based on analyzing row source statistics. But if you're in the active session history mode, then this is what always will be shown, even if the real-time SQL monitoring information is no longer available. And I think this is one of the unique selling points basically of Xplan-Ash, that you can basically generate such an Xplan-Ash report for a past SQL execution, even if the real-time SQL monitoring information is no longer available. The point is that this information here, this activity and then this activity graph here, all of this information is actually based on active session history. As you can see here from the output, that it shows something about samples. So this is the active session history samples that are used here to populate this information in the real-time SQL monitoring report. And since active session history is much longer available and retained also in this DBA hist active sesh history view and corresponding underlying AWR tables, you can actually extract this information even if the real-time SQL monitoring information is no longer available. Of course, execution, actual rows, PGA and IO figures are very, very helpful. So ideally, if you have the diagnostic and tuning pack license, it makes a lot of sense to have a report generated so that you can actually have these monitoring related information in the output. But if you are analyzing some past execution where no real-time SQL monitoring information is available, what Explain-Ash can extract based on active session history usually is also quite helpful, although it of course misses some crucial information. So what are these columns here about? The first column, start, is basically when which is specified in seconds after start of the execution. So this means that this execution plan line here got its first sample in active session history 39 seconds after the execution started. So this is meant with start. So start 39 means on the 39th second of the execution, the first sample was found for this execution plan. Then duration total is what this column is supposed to mean, which means from that starting point here for what was the last sample that was found in active session history for this execution plan line. So this means after the first sample was found on second 39 of execution here in active session history, then 27 seconds later the final sample was found in active session history for this execution plan line. So the total active duration in that sense is then 27 seconds starting from second 39. Now, not for each active session history sample there might be activity for this execution plan line. So this is the duration, meaning of the duration active column. So within this 27 seconds of total activity, meaning from first to last sample found in active session history, this execution plan line was then active for how many seconds? In this case it was, except for 1 second except for one sample point, it was active all the time. So it was active for 26 seconds out of these 27, but we can see here, for example, for these execution plan lines, this one was first time active on the 12th second of execution. The final sample was found 19 seconds later, but within these 19 seconds it was only found to be active for 5 seconds or 5 samples. So that is the meaning of the start, duration total and duration active, which can be quite helpful sometimes to get an idea about the flow of the execution or which part of the execution plan was more active than the other. But as we will see, there are more columns that give more information about that kind of activity. But still, I think it can be quite helpful. I also tried to represent that basically the same information graphically. So this is basically a graph that is supposed to represent from left to right the total execution time or the execution time so far if this statement is still executing. So this is from basically from first sample to last sample, if you want to say so, based on active session history, and you get here this hash sign for each part of this time where this execution plan line was active. So basically it gives you an idea at which point of the execution which execution plans were active. So we can deduce from this graph here, which is also basically reflected in this information. So this is obviously the part of the execution plan, of this parallel execution plan, where execution has started. Then some other execution plan lines were a little bit active, and then we have this part here starting in the middle, around the middle of the execution of the total duration of this SQL execution. And we have this part where it was more or less then active all of the time. These two execution plan lines were then active more or less for the remaining time. It's not total, that's not entirely true. We have this part here, which was then obviously the final part of the execution. So that is the meaning of this graph, that you get an idea from start to end of the available active session history sample information. When were these execution plan lines active? This is in principle inspired by this timeline information here from the real-time SQL monitoring, but in this case these two do not correspond to each other, because this here is based on the real-time SQL monitoring information, which means when was this execution plan line in terms of the internal flow active for the first time, and when it was no longer active. But the internal flow that in operation in the execution plan is active does not necessarily mean that it was actually actively sampled in active session history. So this is based on this internal logic and tells you, okay, this for example, this operation here was active from start to beginning, which does not mean that in active session history you will find this operation here to be active from start to beginning. In this particular case here, you can see that actually no active session history sample was actually sampled for this particular execution plan line, which means that if I look at the corresponding explain-ash report for this execution plan, which is this one, we will see that this execution plan line here, I think it was operation ID number 5, yes, this operation 5 here, although real-time SQL monitoring says it was active basically from start to beginning, in the time active graph and the start, duration, total, active, and so on information here from the explain-ash, you won't see any activity shown at all. So this is based on active session history samples, and this information here is based on this internal real-time SQL monitoring information. So depending on what you want to understand, one or the other might be more helpful. I decided here to use the active session history information to populate this information, because it is available even if the real-time SQL monitoring information is no longer available. So, but to make it clear here that these do not necessarily correspond. So here I show based on active session history sample which operation of the execution plan was active during the execution, whereas this is based on this internal information that you can find in $$ SQL plan monitor. So there is a first active and last active column or something like that available in $$ SQL plan monitor, where this is here based on. Yes, so these are these columns here based on active session history. We have then this activity graph, which is basically pretty much similar to what you get here as activity information from the real-time SQL monitoring. In this case, they are based on the same source, so they should actually correspond to each other. So here, for example, you can see here that we have here 18% of activity, of the total activity in this execution plan line, and you see here then in explain-ash also this 18% and also these 9 samples on CPU. So what the real-time signal monitoring here shows in one pretty graph here, so the percentage and the type of activity in explain-ash output is actually then spread across these two columns. So you have this activity graph, which shows you with this cheap graphics the type of activity. Again, we have this @ sign, which represents CPU activity, and we have this @ sign. We have this asterisk sign that represents non-CPU activity. So you can see here this mixture, like here we have a little bit of CPU activity and a little bit of non-CPU activity. Here we have only non-CPU activity and so on. So that is pretty obvious and more or less corresponds to what you get here. So we see here this is the same kind of information. Yeah, so here you see here this 19%, and see here this CPU samples 48. Yeah. Oh, by the way, this is again, I also I already mentioned this in previous parts of the tutorial. I deliberately chose this example here because, again, this is the example with this multiple DFO trees, and due to this I already explained that this here this activity graph was already misleading, because it shows here a level of activity that is simply not possible. At the degree of 3 you cannot reach 8 active sessions, so this is already some double accounting taking place due to this multiple internal child cursors that get generated for multiple DFO tree plans. And the same happens unfortunately here on this level. Again, these sample counts here are incorrect due to the same double accounting that takes place. So this here again, there are no 48 samples. If we look into the raw active session history information, you would find that there are no 48 samples for this execution plan line in the corresponding active session history information. There are actually 34. That is what explain-ash shows, and I believe in this case that explain-ash does it correctly, does it more correct than the real-time signal monitoring. But in principle, what I wanted to point out is this column here that you see here, this type of activity. In this case, it just differentiates between CPU and non-CPU activity. In the real-time signal monitoring output, you have these nice colors that represent the different type of activity, like here this CPU and direct path read temp. And this detail information you get then in this additional column here in the explain-ash output. So you see here which type of activity and the number of samples. So you can see here this direct path read temp and CPU activity.